Alright, welcome to the class. Today we're going to talk about topic 5, similar triangles of this course, Introduction to Geometry. Okay, first of all, let's have a look at the concept of similar figures. Well, you can compare this concept with the congruent figures. See, very similar concept except that there are trivial differences. Okay, first two figures are similar if one is simply a blown up and possibly rotate or and flipped version of the other. And corresponding angles in similar figures are equal, and the ratio of lengths of corresponding sides of similar triangles is always the same. For example, in similar quadrilaterals, A, B, C, D, and E, H, G, F, illustrated here, we have angle A equals angle E, angle B equals angle H, angle C equals angle G, angle D equals angle F. We also have the ratio of the corresponding parts is a constant number. For example, AB over EH equals BC over HG equals CD over GF equals DA over FE equals AC over EG equals BD over HF. And we denote these figures as similar by writing like this. ABCD is similar to EHGF. Well, intuitively speaking, when you have the corresponding parts have the same ratio and corresponding angles are equal, then possibly these two figures are similar with each other. And again, in this course, we focus on discussion of the similar figures, similar triangles. So let's do a quick exercise. Given that triangle ABC is similar to triangle YXZ, which statement below must be true? Okay, for example, this is triangle ABC. There's another triangle XYZ. These two triangles are similar. ABC, Y, X, Z. So Y is here, X is here, Z must be here. Remember, we need to write the corresponding vertices in order. Okay, I'll give you 1 minute to think about that, and after that, we'll have a look at the solution together, okay? All right, have you finished? Let's have a look at the solution. Okay, if triangle ABC is similar to triangle YXZ, we write the corresponding vertices in order, right? And similar triangles will have proportional size. So we have AB over YX equals AC over YZ, which also equals BC over XZ, right? Because of the similarity. Therefore, AB over YX equals AC over YZ. This is correct. So this is true. For statement B, AB over BC equals YX over YZ. So we can, because we have AB over YX equals BC over XZ, so we can just move BC here and move YX here, right? So this gives us AB over BC also equals YX over XZ, right? This involves use of a little algebraic knowledge here. So this is also true. And for statement C, AB over XZ equals BC over YX. This is not necessarily true, right? Because from the given information here, we cannot derive such a statement, so not necessarily true. And for statement D, AC YZ. Okay, because we have AC over YZ equals AB equals YX, right? Then the cross product will equal, so AC times YX should equal AB times YZ. So this is also true. For statement E, and from these proportional sides, we cannot derive this equation necessarily. So again, this statement is not necessarily true. Any questions? Alright, then let's consider another exercise. Suppose you're given triangle ABC is similar to triangle ADB, and we know side AC equals 4, side AD equals 9. What is AB? Okay, if you get answer, please give me an answer in the chat box. What is AB? What is the length of AB? Amber, Leo, Neil, Michelle. Okay, give me an answer in the chat box. No, it's not a fraction. Okay, remember for similar triangles, we write the vertices in order, right? Actually, in such a question, you don't have to draw the diagram because these vertices are written in orders. So if you have triangle ABC is similar to triangle ADB, we must have, or could also write it this way, because of this, we have AB over AD, right, equals AC over AB, right? Can you see that? Because they are the corresponding sides. Therefore, we have AB squared equals AC times AD. And you are given the lengths of AC and AD, right? So AC is just 4, AD is just 9. So that equals 36. Therefore, we know 6 squared will get you 36. So AB is just a 6, right? Can you follow me? Remember, similar triangles will have proportional sides, which means the ratio between the corresponding sides should be a constant number. Okay, now the problem is that how do we determine if two triangles are similar or not? Remember, when we talk about congruent triangles, we have 4 theorems can be used to determine if two triangles are congruent, right? Can you recall that? So for congruent triangles, we have either SAS or SSS, AAS, and ASA, right? 4 theorem we can use to determine whether two triangles are congruent. And similarly, we have a series of theorem we can use to test if two triangles are similar. So the first one is called AA similarity, which states that if two angles of one triangle equal two angles of another, then the triangles are similar. For example, in this diagram below, if you know angle A equals angle D, angle B equals angle E, then that implies triangle ABC is similar to triangle DEF. Therefore, we have the corresponding sides are proportional. This is the first theorem we can use to determine whether two triangles are similar. And the problem is that, can you prove this theorem is actually true? Okay, I'll give you 2 minutes to have a look at this theorem here. You should write this down on your notebook. And then, if you have done so, please try to think how you can prove this theorem is actually true. Okay, have we finished? Now let's talk about how we can prove this theorem is actually true. Question is, suppose we have two triangles here, ABE and ACD. Given angle ABE equals angle ACD, can you prove these two triangles are similar? That is a question. Okay, so far we don't know any theorem that we can use to prove two triangles are similar, right? Therefore, we can use only the definition. Two figures are similar if one is simply blow up and possibly rotate or flip one of the other. And corresponding angles in similars are equal, and ratio of the length of the corresponding sides of similar triangles are always the same. So you need to prove that corresponding angles are equal, right? First, prove corresponding angles are equal. The next, prove that corresponding sides are proportional. And from this graph, we know it's obvious that corresponding angles are equal, right? So let's try to prove, write the proof here. You can say it is obvious that the corresponding angles are equal, which means angle BAE equals angle CAD, angle ABE equals angle ACD, and angle AEB equals angle ADC, right? This is obvious. Next, you need to prove the corresponding sides are proportional, which means the ratio between two corresponding sides is a constant. So how do you prove that? Okay, let me write it here. So we could connect these 2 points, and we could connect these 2 points, and let's say we can draw section CE and section BD, okay? And because, let's consider these two areas, ABE over ACE. This equals, ABE is this little triangle here. ACE is a larger triangle here, right? Because it shares the same height from point E. So the ratio between the two areas is given by AB and AC, right? And similarly, the area between ABE and area of ABD is given by AE over AD, right? And because the area of BCE equals the area of BDE. Can you see that? BCE is here. BDE is this triangle here because they share the same height, which is the distance between these two parallel lines, right? Because we know these are corresponding angles. Corresponding angles are equal in any case these two lines are parallel. If these two lines are parallel, then the distance between the two lines are equal anywhere, right? So these two triangles have the same area. Therefore, we have the area of ACE also equals the area of ABD. Can you see that? Because AC is simply this triangle plus this triangle. And ABD is this triangle plus this triangle. If BC equals BDE, then the area of ACE equals the area of ABD, right? And put that into that equation. We know if ACE here equals ABD here, then ABE is the same. Then we will have AB over AC equals AE over AD, right? And therefore, if AB over AC equals AE over AD, that means AB over BC also equals AE over ED, right? Can you follow me? Okay, then if you let AB equals, for example, A, and BC equals B, and AE equals A times another letter K, ABK belongs to the real number set, then we know ED must equal B times K, because you need to ensure this ratio is a constant, right? Where A, B, K belongs to the real number set, and A, B, K are not zero. Can you follow me? Okay, then let's start from here. Continue the proof. Okay, we are currently here now. Alright, then we can draw section EF parallel with section AC here at F. Then using the same method, we can use the same method we can prove. Okay, so in previously, if BF is parallel with CD, we proved that AB over BC equals AE over ED, right? Then similarly, if you have EF is parallel AC, you can prove actually ED over AE should equal DF over FC, right? Using the same method. So we can prove ED over AE must equal DF over CF, which also is B over A. So we can let DF equals BM, then we know CF must equal A times M. Of course, A is not zero. M is not zero, and M belongs to the real number set. because we know section BE is parallel with section CF, and section BC is parallel with section EF, then we know BE must equal CF must equal A times M, right? Therefore, we know BE over CD is AM over AM plus BM, which equals A over A plus B, which also equals AB over AC, which also equals AE over AD, right? Therefore, actually, you have proved that BE over CD equals AB over AC equals AE over AD, which means corresponding sides are proportional, right? And previously we have proved corresponding angles are equal. That means we have completed the task. These two triangles are indeed similar. So triangle AB is similar to triangle ACD, right? Which completes the task. If you know two angles from a pair of triangles are equal, another pair of angles of the two triangles are also equal. According to AA similarity, we can conclude that these two triangles are indeed similar with each other, right? You follow me? Okay, in a summary, if two angles of one triangle equals two angles of another, then the triangles are similar. This is called testing theorem 1, AA similarity. Alright, if you don't have any questions, let's consider an exercise here. In the figure at right, if MN is parallel with OP, OP is 12, MO is 10, and LM is 5, can you find the length of MN? Alright, I'll lead you through this one. Seems that these two triangles are similar, right? But still, you need to prove that. Okay, because we have a pair of parallel lines, this angle equals this angle, and they share the same angle here. Therefore, we know angle L equals angle L, and parallel with OP gives you angle LNM equals angle LPO. Therefore, we know triangle LNM is similar to triangle LPO, right? Therefore, corresponding sides should be proportional. So LM over LO equals MN over OP. And because LO equals LM plus MO equals 15, we now have 5 over 15 equals MN over OP, 12. Therefore, we have MN equals 5 times 12 over 15, which gives you 4, right? Any questions? Okay, very straightforward, right? So this is a typical setup of two similar triangles. If you have a triangle here, a section is parallel to the bottom line here, then this triangle is similar with the larger one. Okay, very typical setup of a pair of similar triangles. Okay, next, let's have a look at another exercise. Another typical setup of pair of similar triangles. So length in the diagram marked, and WX is parallel with YZ. Can you find PY and WX? Okay, again, I'll lead you through this question here. Because these two angles are vertical angles are equal, right? And a pair of parallel lines give you a pair of equal angles here. Then we know, let's say, because angle XPW equals angle YPZ, and a pair of parallel lines indicates corresponding angles are also equal. So angle XWP equals angle YZP, right? Two pairs of equal angles indicates triangle WXP is similar with triangle ZYP, right? Remember to write the corresponding vertices in order. Hence, we have PX over PY equals WX over ZY which also equals WP over ZP, right? So substitution will give us PX equals 3 over PY equals WX over 12, which equals 5 over 10, right? Therefore, we can solve PY equals 6 and WX equals 6 as well, right? You follow me?
If I just wrote like PY equals 6 and WX equals to 6, like without any proof, will the result or in the exam will they give me marks?
Well, if it's in an exam, if it's a fill in the blank type of question, you can just directly give the answer. Otherwise, how should you know this length is 6? If it's a short answer, you need to give your logic there, right? Why do you think it's 6? It seems like 6, but you need to prove that, right? Okay, and another typical setup of a pair of similar triangles illustrated here. Suppose we have a right triangle ABC, and we have a height BD. Given AD is 3, AB is 5, and BD is 4, can you find BC and DC? Also, in this setup, we have actually 3 similar triangles, right? This triangle is similar with this one here, actually, because this angle equals this angle, right? Oh, sorry, mistake here. This angle equals this angle because if they add this angle, they will get both 90 degrees. So this angle equals this angle, and this angle equals this angle, which is 90 degrees. So according to AA similarity, these two little triangles are similar, and they are all similar with the larger triangle ABC, right? So you could use this property to find BC and DC. So we could write it like this because angle BAD equals angle CAB, and also angle BDA equals angle CBA. We have triangle BAD is similar with triangle CAB by AA similarity, and therefore we have BC over BD equals AB over AD. which equals 5 over 3, right? Therefore, we know BC is 5 over 3 times BD, which gives you 20 over 3, right? And similarly, we can prove triangle BCD is also similar with triangle ACD. So this also according to AA similarity, right? Therefore, we have CD over BD equals BC over AB, right? Which equals 20 over 3, then over AB, AB is 5. So this gives you 4 over 3. And then we know CD equals 4 over 3 times BD. This gives you 16 over 3, right? Any questions? Again, we have just seen 3 typical setup of similar triangles, okay? So get yourself familiar with these patterns. And let's consider another exercise if you don't have any questions. Otherwise, just if you want to pause, just let me know, okay? In triangle ABC, AB equals AC, BC equals 1. Angle BAC equals 36 degrees. If you let D be the point on side AC such that angle ABD equals angle CBD, can you prove triangles ABC and BCD are similar? Next, find section AB. Okay, you need to, if there is no diagram, it's better to draw the diagram by yourself, right? So here I'll just lead you through the diagram. So basically you have a triangle ABC, AB equals AC, so that's isosceles triangle. Then we have a point here, D, and we know AB equals AC, BC equals 1. ABD equals CBD. And this angle here is 36 degrees. That's all we know, right? Okay, let's say because we know AB equals AC, you want to prove the smaller triangle here is similar to the larger triangle ABC, right? It seems that they already share this angle here. So probably we can prove, if you can prove this angle is 36 degrees here, then these two triangles are of course similar, right? So let's see if we can find that angle. So angle C is 180 degrees minus 36 degrees over 2, right? Which gives you 72 degrees, which also equals triangle ABC, right? Can you follow me? And angle ABD equals angle CBD. This is a given information, which equals 72 degrees over 2, which is 36 degrees. Then we can find this angle is actually 36 degrees, right? And because angle BAC equals angle CBD, which equals 36 degrees, and angle ABC equals angle BCD equals 72 degrees. We have triangle ABC is actually similar to triangle BCD according to AA. Okay, do not forget to write the theorem you're using here. So that completes the first question. Next, find AB. So probably if you have a pair of similar triangles, probably we'll use proportional size to find the length of AB, right? So because angle BDC equals angle C, which is 72 degrees, therefore we know BD equals BC equals 1, right? So this length is also 1. And because angle A equals angle ABD equals 36 degrees, we know AD equals BD, which is also 1 here, right? And we know AB over BC equals BC over AD, BC over CD. This is according to similarity. And if we let AB equals X, we want to find AB, right? So if we let AB equals X, then we know CD must equal X minus 1, right? Therefore, we have X over 1 equals 1 over X minus 1, right? So basically, we have an equation in terms of X. So X squared minus X equals 1. This gives us X squared minus X minus 1 equals 0. Do you know how to solve an equation like this? Have you learned that in algebra? That's called quadratic equation, right? First, let's find delta. Delta is b squared minus 4 times a times c, which is 4, which is 5. And then we have x equals 2a negative b plus or minus square root of 5. Apparently 1 minus square root 5 is negative. X is the length, so we only choose a positive. So x equals positive 1 plus square root 5 over 2. Can you see that? Any questions here? Okay, if not, let's consider one last question before we taking the break, okay? And next exercise, consider this question here. If we have AB equals X, can you find X in terms of Y, given the diagram below? Okay, remember these arrows here indicates we have a pair of 3 parallel lines. AB is parallel with CD, is parallel with GF. Alright, let's have a look at the solution together. Because we know AB is parallel with CD, we have angle A equals angle DCE. And angle ABE equals angle CDE, right? Therefore, we have triangle ABE is similar with triangle CDE by AA similarity. Therefore, we have 4 over x equals 5 over 5 plus AC, right? And cross multiplying gives 20 plus 4AC equals 5x. So AC equals 5x over 4 minus 5. And similarly, from FG is parallel with AB, we can have triangle FGH is similar to triangle ABH, right? Which gives 7 over 7 plus y plus 5 plus AC equals 5 over x, right? And then we can substitute AC using this expression here. Substitute there. You will get 7 over 7 plus y plus 5x over 4, right? Equals 5 over x. Again, this gives you a equation in terms of x and y, which means by cross multiplication, we have 7x equals 35 plus 5y plus 25x over 4, right? And remember, we need to solve x in terms of y, so separate x and y's. So 3x over 4 equals 35 plus 5y, which means x equals 140 over 3 plus 20y over 3, right? Okay, have a look at the solution by yourself, and let's take a 5 minutes break. 5 minutes break, okay? Okay, let's see the next question then. Okay, next we'll talk about the second theorem we can use to determine similarity, which is called SAS. This statement tells us that if two sides in one triangle are in the same ratio as two sides in another triangle, for example, in the diagram below, if you have AB over AC equals D over DF, and the angles between these sides are also equal, as angle A equals angle D below, then the triangles are similar. Note that we can also write that ratio equally as the ratio of corresponding sides in the triangles. For example, you could also write AB over DE equals AC over DF. They are actually the same thing. Then this is called SAS similarity. But because of the time constraints, I'm not gonna provide the proof here. You can read my proof after this lesson, okay? A possible proof of this theorem will be provided to you in the lecture slides. So try to figure out by yourself first. Okay, first of all, write this theorem down on your notebook. We're going to use this a lot, okay? Now we have CAA similarity and SAS similarity. And if you have done that, think about how we can prove SAS similarity is true. Okay, finished? Okay, I'll give you a quick explanation why SAS is true. Okay, so the question is, given AB over AC equals AE over AD, how we can prove ABD is similar to triangle ACD?
I think when we proved like AA similarity, we had like proved this step.
Yes, you can use AA, right? Use AA similarity because we have learned that. Then you can use AA similarity. So a possible proof is illustrated here. You can read this by yourself. First of all, draw BF parallel with CD. Well, it seems BE is parallel with CD, but still you need to prove that, right? So let's draw BF is parallel with CD and intersect with AD at point F. Then we know angle ABF, this angle here, equals angle ACD, right? Because this line is parallel with this line. Parallel lines gives us corresponding angles are equal, right? And because angle BAF equals angle CAD, because they're the same angle, therefore we know triangle ABF must be similar to triangle ACD, right? According to AA similarity, right? You see that? Therefore, corresponding sides are proportional. So AB over AC should equal AF over AD, right? Therefore, we have AF equals AB times AD over AC. And according to the given information, we know AB over AC equals AE over AD. Therefore, we also know AE also equals AB times AD over AC. So basically, AF and AE have the same length, right? If AF and AE have the same length, that means F and E are actually the same point. Can you see that? They are actually the same point. So AF equals AE. So F and E are the same points. We have just proved ABF is similar to ACD, and then we know F and E are the same points. Therefore, we have triangle ABE is similar with triangle ACD, right? So this is the logic behind SAS similarity. Did you get it? Again, this theory can be proved. Okay, then let's use this theory to solve a series of exercise questions. We have 2 questions to solve, okay? You could use either AA or SAS similarity. So given AC equals 4 here, CD equals 5, AB equals 6. Can you find BC if the parameter of BCD is 20? Okay, I'll give you a hint. So AD equals 9, right? Also note that 6 over 9 equals 4 over 6, right? So what does it tell you? Because AC over AB equals 4 over 6, which is 2 over 3, and AB over AD equals 6 over 9, which is also 2 over 3. And they share the same angle. Therefore, we know triangle ACB is similar to triangle ABD by SAS, right? 2 pairs of proportional sides and angle in between are equal. then how do you know the length of BC? BC over BD also equals 4 over 6 or 2 over 3, right? So that means BC is, okay, let's say BD. BD is 3BC over 2, right? We know BC plus BD plus CD equals 20. And substitute BD there. We have BC plus 3 over 2 BC plus CD. CD is given there, 5, which is 20. So this gives us 5 over 2 BC equals 15. Therefore, BC is 15 times 2/5. So that's 6, right? Any questions? Okay, if not, let's have a look at the next one. In the diagram below, angle PQR equals angle PQA. PRQ equals PQA equals 90 degrees. QR equals QA. And angle QPC equals angle RPC. These two angles are equal. First of all, can you prove angle QCB equals angle QBC? So you need to prove QCB equals angle QBC. These two angles are equal. Then prove RA is parallel with PB. Okay, first one is not that difficult, right? Okay, we can say angle QBC equals angle QBP, which equals 90 degrees minus angle QPB, which equals 90 degrees minus angle RPC, right? And that equals angle PCR equals angle QCB. Can you see that? Because basically this angle plus this angle is 90 degrees. This angle plus this angle is also 90 degrees, and this angle equals this angle. So we know these two angles are equal, right? And for the second one, I'll give you 1 minute to think about that. RA is parallel with PB. So you need to prove RA is parallel with PB. Okay, let's have a look at the solution. Because QBC equals angle QCB, right? We have just proved that. Then we have QB equals QC. And because QB equals QC, and also QA equals QR, we have QB over QC equals QA over QR, right? Therefore, we know triangle QBC must be similar to triangle QAR by SAS, right? Therefore, we have angle QCB must equal angle QRA, right? If QCB equals QRA, then corresponding angles are equal, indicating the two sections are parallel. So PB must be parallel with RA. Okay, any questions? Okay, if not, let's see the third theorem we can use to determine similarity, which is called SSS. This theorem tells us that if each side of one triangle is the same constant multiple of the corresponding side of another triangle, then the triangles are similar. For example, in the diagram above, we have AB over DE equals AC over DF equals BC over EF. Then we have triangle ABC is similar to triangle DEF. Therefore, corresponding angles are equal, right? This is the third theorem we can use, so please mark this down on your notebook. Now we have three theorems that can be used to determine similarity of triangles. And for those of you who have already done this, think how we can prove this theorem is true. Okay, which means if you have a triangle here, ABC, another triangle PQR, given AB over PQ equals BC over QR equals AC over PR, can you prove triangle ABC is actually similar to triangle PQR? If you have already finished that, think about this question, okay? Alright, so let's see the proof here. We can actually draw PS equals AB. And from this point, draw another line. ST is parallel with QR. This is possible, right? Use only straight edge and a compass. And because angle P equals angle P, angle PST equals angle PQR. This is according to a pair of parallel lines. We have triangle PST similar to triangle PQR by AA similarity. Therefore, corresponding parts are proportional, which means PS over PQ equals ST over QR equals PT over PR, right? Because given information states that AB over PQ equals BC over QR equals AC over PR, then we know AB must equal PS, BC must equal ST, AC must equal PT, right? Then according to SSS theorem, we can prove triangle ABC is actually congruent with triangle PST. So basically this triangle here is congruent with triangle ABC. Because we have already proved PST is similar to PQR and ABC is actually congruent with PST, then we know triangle ABC is similar to PQR, right? So again, we can actually prove SS similarity is true. Now we have three tools to use to determine if two triangles are similar, right? AA, SAS, or SSS. Do you get it? Okay, let's do an exercise. Given the side lengths shown in the diagram, can you prove AE is parallel with BC and AB is parallel with DE? Again, usually we'll need to use angles to show the segments are parallel, right? Either use the sum of the two interior angles equals 180 degrees, or more straightforward, using corresponding angles are equal. But all we have now here are sides. So probably you should look for similarity first, right? So can you spot any equal ratios there? Note that 12 is twice of 6, right? And okay, probably we don't use that. So probably use, alright, 12 is twice of 6, 10 is twice of 5, and 4 plus 4 is 8, which is twice of 4. So we have AB over DE equals AC over AD equals BC over AE, because these two triangles seems to be similar, right? And actually they have proportional size. Then we can conclude triangle ABC is actually similar to triangle DEA. Remember, you need to write the corresponding vertices in order by SSS similarity. Therefore, we have angle BAC equals angle EDA. Therefore, AB is parallel, yes, with DE. Michelle?
I was going to say, like, can we do it like, we just double the size of triangle ABC, like double the length of AB, AC, and CD, then we created a parallelogram, and then using corresponding angles, we would know that AB parallel to
Yes.
D.
Yes, that's actually the same thing. If you double every length of one triangle to get the other one, then you're actually using SSS, right? So basically it's the same thing. That's called SSS. And SSS tells you similarity. And because angle DAE equals angle ACB, then we know AE is parallel with BC, right? Okay. Any questions? Alright, if no questions, let's consider another exercise. Now you have three theorems to use to prove similarity, so let's put them all together. You could use either AA, SAS, or SSS, right? So let's consider this exercise here. In this diagram, you are given D is parallel with BC, and the segments have the length shown in the diagram. Can you find X, Y, and Z? Okay, because you have a pair of parallel lines, DE and BC, right? So immediately we should know this triangle is similar with this triangle, right? Because we have this angle equals this angle, and we have another pair of vertical angles. AA similarity gives us these two triangles are similar, right? So we could say since ED is parallel with BC, we have angle DEF equals angle FBC, and because angle DFE equals angle CFB, we have triangle FBC is similar with triangle FED. Be careful, you need to write the vertices in order by AA, right? Therefore, we know FC over FD must equal BC over BE equals FB over FE equals 60 over 36 equals 16 over 9, right? So solving for x and y, we have x equals BC, which equals 16 over 9 times DE, which is 80, and y equals FC, which equals 16 over 9 times DF, which is 48, right? Then if you have found x and y, then using another pair of similar triangles, for example, this triangle here, ADE, is similar with the larger one, this triangle, right? Because this angle equals that angle, they share the same angle here, right? So again, I'm not gonna write all of the statements, so you could say because of two pairs of equal angles, we have triangle ADE is similar with triangle ABC, right? Therefore, we have AE over AC equals DE over BC. Well, input Z and X there. AE is Z. AC is Z plus 60, right? DE is 45. BC is X. X is 80. We have already solved that. So that'll give us 80Z equals 45Z times a plus 60 times 45. So we have 35Z equals 60 times 45, which eventually gives us z equals 450 over 7, right? Did you get it? Yes, Michelle?
Like, in what grade will we usually get in touch with this stuff in school?
I mean, in China or in Canada?
In China.
Have you learned this? Oh, you are homeschooled, right? Okay, I think grade 7.
I think in grade 7 we just learn triangles, like the basic things about triangles.
Yeah, sometimes grade 8, 7 or 8. But it's not that hard, right? Any questions?
It's not as hard as I expected it should be.
Yeah. So any questions, just let me know, okay? So my job is to answer your questions, explain everything that you feel confused. Otherwise, you can just read the books, right? Okay, one last piece of trivial concept. If we have BC parallel with the as shown here on the right, and line BD and C meet at A as shown here, then of course you can prove this triangle is similar with triangle ADE, right? So directly you will have AB over AD equals AC over AE, right? If this is true, then you can also prove AB over BD equals AC over CE, right? Can you prove this by yourself? It's very easy, right? Because if you know this one is true, then AD over AB must also equal AE over AC. Then AD is actually AB plus BD, right? Then AE is AC plus CE over AC. So you will get 1 plus BD over AB equals 1 plus CE over AC. So this will give you BD over AB equals CE over AC. So if you just flip both sides, you will get this conclusion. AB over BD equals AC over CE, right? Any questions? So that's the first one you should know. Not only the corresponding parts are equal, are proportional. You can also prove AB over BD equals AC over CE, right? That's the first one you should know. And secondly, if two triangles are similar such that the size of the larger triangles, larger triangle are k times the size of the smaller, then the area of the larger triangle is k squared times that of the smaller. The relationship holds for any pair of similar figures, not just for triangles. Okay, if for triangles, can you prove this is true? Suppose you have a triangle here and another triangle. If the two triangles are similar, their ratio of size equals k squared. where k is the ratio between the corresponding sides. Which means suppose we have A, B, C here, and AK, BK, CK here. Then suppose the area of the first one is A, let's say S. Then the area of the second one is K squared S. Can you prove this is true? And that's not difficult, right? Suppose we have a height like this. Then if this height is h, we know this triangle must also be similar with this one, right? According to SAS. Then if this is h, then this length is h times k, right? Then S equals 1/2 of CH, and let's say S prime is the area of the second triangle, which is 1/2 of H times K times C times K, which gives you 1/2 of K squared CH. So if you compare these two expressions, then we know S prime must be K squared times S, right? So if two triangles are similar, such that the sides of the larger triangle are k times the size of the smaller, then we know the area of the larger triangle is k squared times that of the smaller. And this is the second you should know, okay? Alright, then let's consider one exercise. Given triangle ABC is similar to triangle YZX, and area of triangle ABC is 40. The area of triangle YZX is 360. AB equals 9. BC equals 12. Can you find each of the following? A. Length of YZ. B. The length of the altitude to side XZ of triangle YZX. Again, diagram will help you to visualize the question. Okay, we know the area of the first triangle, area of the second triangle. Then we know the ratio between the two areas, right? So ABC over YZX is 40 over 360, which is 1 over 9. And also triangle ABC is similar to triangle YZX. And this tells us that AB over YZ should equal AC over YX should equal BC over ZX, which is the square root of that ratio here, right? Which equals 1 over 3. Therefore, we know YZ is 3 times AB, right? Which is 27. You get it? That completes the first question. And second question, length of the altitude to side XZ. So if you know ZX, you know the area of that triangle, then you know the H, right? Okay, first of all, ZX equals 3BC, which is 36. And we also know 1/2 of ZX times H equals the area of YZX, which gives you 360. And that tells us H equals 2 times 360 over dx. dx is 36. So that'll give you 20, right? So 20 is the number you're looking for. Any questions? Okay, so that's the last piece of knowledge you should know. And we have, because of time constraints, we have 2 questions remaining. So please copy these 2 questions on your notebook. Try to finish them after this class, okay? So consider these 2 questions as part of the homework. Also, you can download today's homework from Google Classroom and try to finish as much as possible before the next lesson, okay? Alright, so if no questions, I'll see you next time then. Bye.